Okay, firstly, draw the graph of 4x plus 1. So when x is 0, gx is 1, so that would be there. When x is 1, that would be a 9. Sorry, what am I saying? That would be a 5. So that's there. And that's kind of enough because it's linear. I'll just put in one more. When x is 2, it'd be a 9. Just like there it looks like. So, whoa, it's not quite linear, but you get the idea. Use substitution to verify that fx is less than gx when x is 1.9. So fx, that's 3 power 1.9, is that less than 4 times 1.9 plus 1. So actually I can see that I drew it quite poorly because it should be, okay, let's see. Well, do you know what? Let me just calculate that first. Okay, 4 times 1.9 plus 1, that's 8.6. And then 3 power 1.9 is 8.06. So the exponential is below the linear at 1.9. Yeah, that actually looks okay. No. Okay, that's done. That's done. Now prove that Fn is greater than or equal to Gn when n is less than or equal to 2. Okay, we know the story here. We want to case n is 2. So Fn, so that's 3 power 2, is that more than or equal to 4 times 2 plus 1 is 9 more than or equal to 9, so that's true. 2, we assume it's true for case n equals k. That is 3 power k is more than or equal to 4k plus 1. 3, we're required to prove case n equals k plus 1 is true, i.e. that 3 power k plus 1 is more than or equal to 4k plus 1 plus 1. So from 2, we have 4k plus 1 is less than or equal to 3 power k. If we multiply both sides by 3, we get this, which then is 12k plus 3 less than or equal to 3 power k plus 1. Which is so which means next now, so now we require to prove that 4k plus 1 plus 1 is less than or equal to 12k plus 3, which means 4k plus 5 is less than or equal to 12k plus 3, 2 less than or equal to 8k, k more than or equal to a quarter. Well, this is true since we know that k begins at 2, which is true since k is more than or equal to 2. So then we finish off with our logic. 1 plus 2 plus 3. That means it's true for n equals 2, 3, 4, etc. Okay.